Welcome to Nearpod 5.6 Covalent Lewis Dot Structures. As a general reminder, please make sure to title your notes this so you can refer back to it. And by the end of the video, these are the 3 key ideas you need to know for this particular lesson. So in our Zoom class today, we talked about identifying patterns of how these elements combine to end up with what we call these particular Lewis structures, right? So essentially, these structures that we're looking at are all what we call covalent molecules. And covalent molecules are when non-metal elements combine together to form a bond by sharing electrons, and they end up looking like this, right? So notice that all the elements we were looking at today are actually non-metals. And just as a general reminder, the ones highlighted in gold or yellowish color are the non-metal elements, right? So when we're talking about covalent molecules, we're talking about only elements from this goldish yellow part of the periodic table. Before we start on our actual lesson today, I want to review a couple of key differences between covalent molecules, what we're going to learn in this video, and ionic molecules, what we've been learning from Nearpod lesson 5.1 to 5.5, right? So when we're looking at ionic molecules, they tend to be different types of salts, and they have the same structure almost every single time. So a very cube-like, squarish, cubish shape, right? So if you look very closely at the salts that you eat, you'll kind of see that they come in this cube-like shape as well. When we're talking about the shapes of covalent molecules, these are often items that don't contain metals. In fact, they never contain metals. So things like water or organic material, not including the salt ions inside of them, but in general, things that are mostly made up of covalent molecules tend to be organic looking matter, kind of like this stuff, living stuff, right? So when we zoom in to the actual atoms and elements and molecules when they combine, right? If we could look at ionic molecules, they're kind of elements just donating electrons to each other. On the other hand, when we're drawing covalent molecules, since they tend to be very closely shared with each other, right? They kind of have a more variety of shapes, right? So oftentimes when we're talking about shapes, we'll talk about covalent molecules, right? And as a reminder again, that ionic molecules are made up of at least one metal and one non-metal ion. So for example, NaCl, Na, sodium, and Cl, chlorine, to make sodium chloride, or more commonly called table salt, is an ionic molecule. It's made up of one metal and one nonmetal. For covalent molecules, they're made up of nonmetal elements only. So if I give you another example, like H2O, right? Both hydrogen and oxygen are non-metal elements, and covalent molecules are only made up of non-metal elements. So a key thing you should have in your notes is the definition of ionic and covalent molecules, as well as the common elements that they're made of. Right, so covalent, non-metal elements only. Ionic molecules, at least one metal and one nonmetal. Finally, before we go over how to draw this stuff, the Lewis dot structure, or sometimes referred to as just Lewis structure, right? I have to give you the molecular formula first, or maybe a name. So essentially, a reminder that the molecular formula is just the element symbols and how many of each element I have, shown by a number on the bottom right-hand corner, known as the subscripts. So here, on the left-hand side in red, are the steps for how to draw a Lewis dot structure if I give you the molecular formula of an element like NF3. So please make sure you have at least an abbreviated version of these steps or an example problem drawn out, right? Okay, so step number 1 is to draw the Lewis dot diagram of each element separately, right? So notice here that I have 2 capital letters signifying the fact that I have 2 different types of elements. So capital N, nitrogen is my first element, or N, and then I have F3, right? So fluorine is my other element, and I have 3 of these. So I'm going to draw the Lewis dot diagram of each element separately. And if you don't remember, recall that in Nearpod lesson 5.1, when you're drawing a Lewis dot diagram, you're just drawing the valence electrons for each element. And to figure that out, it's the group number A that is equivalent to the number of valence electrons you need to draw. So if I look up F, or sorry, this is N on my periodic table. So element N is located here, and it is in group 5A. So therefore, I need to draw 5 valence electrons in this order as shown here, right? So that's going to be 1, 2, 3, 4, 5. So for F, I'm going to do the same thing and figure out how many valence electrons or dots I need to draw for F. So checking my periodic table, F for fluorine is here. It is in group 7A, so it will have 7 valence electrons. So following the same order, first one on top, second one on the right, third one on the bottom, fourth, fifth, sixth, seventh. Right. So oftentimes when I'm doing this on a sheet of paper, I don't have all these colors. And if you also don't have a whole bunch of colors to spare, just to tell them apart, sometimes I like to draw different shapes for the valence electrons. Right. So 1, 2, 3, 4, 5, 6, 7. Right. And for this third F, I'm going to do the same thing. It's still in group A. I'm just going to draw X's. So 1, 2, 3, 3, 4, 5, 6. So notice that I didn't do this in order. Once you figure out the order of the first one, they kind of all look the same, right? So don't worry if you don't do all of them in order. It's just like a good habit to keep if this is kind of new to you. So we've completed step 1. We've drawn all the Lewis dot diagrams of each element separately. Step 2 says to pair all the single electrons with another element, right? So I want you to notice that for N, for example, this top one, these two are paired up. So I'm looking at the top, the left, the right, and the bottom. So this top one is paired up, but my left, my right, and my bottom only have 1 electron. So each one of these are missing 1 electron. So they're going to bond with these Fs. So notice that there are 3 single electrons and 3 Fs, right? So if you can't see or imagine your head right away how these 4 elements will bond, let me show you something in a slightly different way. So here I've drawn out the same thing that we did earlier, right? And let me go over what I mean by this. So notice that N, these 3 are single, right? So this first F, if I could imagine moving these, right, this F can connect here. So notice that in this F, this dot is single and this dot is single. So these two are going to connect and form a bond together, right? All the single electrons want to be paired up. They want to get together. And so that's why they're going to pair up like so, right? So here for this F, if I keep it like this, it doesn't quite work. But remember that when we're dealing with atoms and elements, they all exist in the real world, right? So we can turn them and rotate them so that this F connects here, right? And this third F, can you kind of see where it goes? Right, so notice that I can turn it this way and connect it with these 2 single electrons here as well, right? So essentially what I'm going to be left with is something like this, where I have N, 2 electrons on top, and every single time I connect this is going to form a line. Right, so that's 1, 2, 3 lines. I'm basically just copying everything over. Right, so F dot 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 dot. This F, instead of writing the F sideways or upside down, I'm going to put it back right side up, just to make things easier to read, right? And these dots, I'm going to change back to the normal way we draw valence electrons. And this F, instead of X's, I'm going to change them back to dots as well, right? So that's what I mean by connecting all the single valence electrons with other elements. And the last step is just to draw these lines, right? So this is technically my final answer. Okay, so just to recap the steps on this slide, right? So in this section, we did most of steps 2 and 3. So basically in our head or either by doing this, right, we've connected all of the single dots, right? And that is step number 2, pairing all the single electrons with another element that also has a single electrons. So now all these single electrons are coupled up together. They have formed a bond, right? And all the ones that are sharing electrons, so this pink electron comes from F, this blue electron comes from N. These two come from different elements. They're being shared. So I'm going to change those to green lines, and this ends up being my blue line here in my final answer. Another tip, if you can't imagine how these structures form right away, the element with the most single valence electrons is usually in the middle. So notice that N has 1, 2, 3 single valence electrons. And at the end of our answer, it's in the middle, right? On the other hand, each F only has 1 single electron. So So that's kind of a hint to me that it'll probably stay on the outside. Okay, so I'm going to do a second example problem, but I'm going to go a little bit faster this time. All right, so this time going through the steps, I have H2O. So I have two H's, and hydrogen, if I check my periodic table, is in group 1A. So each hydrogen is going to have one valence electrons. O, or oxygen, is in group 6A, so it's going to have 1, 2, 3, 4, 5, 6 valence electrons. Right. Now I'm going to pair all the single electrons with one another. So notice that this one, this one, this one, and this one are single, right? And maybe some of you can kind of imagine how they're going to connect. I might draw it out for myself where this single is going to connect to this single probably, and this one will probably shift down there, right? So that's step one. Let's do step two and actually draw them next to each other. So for O, redrawing O like so. If this H goes on the left-hand side, excuse me, can rotate that H there. And for this H, can go up top like so. Let me fix that dot so it makes more sense. There we go. So now all my single ones are paired up, right? And step number 3 is going to form a line for every electron that's shared, right? So therefore, my final answer, if I just clean things up a bit and make things a little neat, it's going to be O, 2 dots on top, 2 dots on the right, H, H. If I double check using this, because it tends to be easier to manipulate or move things, right? So here I have the same 3 ones drawn, single with single, so this single goes down here, this single will rotate here, haha. So I pretty much end up with the same answer, right? Okay, so at this point, our practice problems are a little bit different because we have to draw things out, and I got some feedback last quarter that drawing things digitally is kind of annoying. So on a separate sheet of paper, any scratch paper will do, draw the Lewis dot structures for these 3 formulas below, and go ahead and upload the image onto the Schoology page for this particular homework. You'll notice that in the instructions part of this assignment on Schoology, it will show you how to upload images onto Schoology as well. And that's pretty much it for lesson 5.6.